The question is like this: using the properties of determinants and without expanding, prove that this determinant is equal to 0. Okay. Now, to solve this question, we take the left hand side. Okay. So in left hand side, we have been given a determinant x a, x plus a, y b, y plus b, z c, z plus c, and this we have to prove that it is equal to 0. Okay. So to solve this question, what I first see here is this, that the column 1 has x, y, z and column 3 has two terms. The first terms are respectively x, y, z and second terms are a, b, c. So if I am going to subtract the terms x, y, z, that is the column 1, from these terms, then I am going to get a, b, c, and this would give me two identical columns. Okay, and I know that if two columns are identical, then the value of the determinant is 0. So this idea I am going to apply to solve this question. Okay, so what I do here, I apply this operation. C3 is changed to C3 plus minus 1 times C1. So what I'm going to do, I'm going to take the elements of C3 and I'm going to add the corresponding elements of C1 to it by multiplying it with minus 1. Okay. So in other words, I'm just subtracting the elements of the column C1 from C3. Okay. So I'm going to get the determinant like this. Here x, x, y, y, z, z cancels out. Okay. So I'm going to get the determinant like this. Two columns are identical. When two columns are identical in any determinant, the value of the determinant is equal to 0. Therefore, this determinant is equal to 0, which is equal to RHS, which proves the given equation. Okay. Now this problem can also be done by the second method. In the second method, what property we are going to apply is that if we have in any column each term as the sum of two different terms, that is, first element is x plus a, second element is y plus b, third element is z plus c, then this determinant can be written as the sum of two determinants like this. Okay, the first determinant is like this, that it has same column 1, column 2, but it has the first terms of the column C3, and the second determinant is having the same column 1, same column 2 and having the second term as the column C3. Okay, so here what I see here is that xyz is identical, column C1 and C3 are identical, so this will be equal to 0. And in this determinant also the column C2 and C3 are identical, therefore this determinant will also be equal to 0. Because both the determinants are equal to 0, this is equal to RHS, and this proves the equation. Okay, so this is how we are going to solve this question. One thing more which is left is that this question can be proved by many methods and you have to just play with the property. Okay, so you will be finding that there are many methods of solving the same question. Okay.